the way they put them, because they run a railway line underneath and they hang bars. Your eye think that the top one is different, although they're equal, simply because you think it's at the back.
That's right.
And those, or like the classic one where you have to count like when they pass a ball to each other, and then there's this guy in the monkey suit that walks at the back and nobody sees it.
Yeah. No, that's right. But I find it rather ironic, but also very fitting that what I was working on in the late 1970s, after a gap of about 30 odd years, has come in again, using completely different mathematical techniques, but it's a very similar problem. But in fact, if you trace where the mathematical techniques came from, you work your way all the way back to what I was doing in the 1970s. There's a natural progression.
I think that's true of a lot of science, because it either goes round in circles or it goes off in a whole new direction. Because I remember...
No, a lot of it does a spiral.
That's right.
Yes.
It goes in circles, but it comes back on a different level.
Yeah.
Yes.
But I remember... most people are too young to remember this, but I have older brothers, and when they did their 11 pluses, they got extra points for being born late in the year.
Yes.
In the school year, so that
Yes.
if you were born in September, it was harder to pass 11 plus than if you were
Yes.
born in August.
Yes.
And that was known in the 50s. And then I remember seeing there was a big thing in the papers a couple of years ago about how children born late in the school year
Have difficulties, yes.
have more difficulties than the ones born, and I thought, but they knew that in the 1950s. So why are they suddenly saying, we're doing this research, and researchers have shown? And you thought...
Well, in 1946, when I failed the 11 plus,
sorry.
having been born on September the 19th,
Yeah.
I was forgiven, having failed it, by going to a grammar school.
Yeah. Because
of that same thing, so
And
it was even known then.
yeah. Well, I mean, it was just because, and my brother, who was born in May, only passed the 11 plus because he was born in May.
Yes, yes, there was a lot of that.
I'm sorry, at what age do children do 11 plus?
They don't anymore.
They don't
11.
More.
11.
Yes.
What was it actually? Because
If you did well, you went to grammar school. If you did less well, you went to a different kind of school.
But if you have,
There wasn't even secondary moderns when I did it.
no, it was like that also.
Yeah.
The younger you were, the less time you'd had to study, and you were competing against older people, so it was harder for you.
Yes,
Okay. But they were saying that even the matter of the 2 or 3 months.
made a difference
Made
at
a
that time.
I can see that because
Yeah.
but yeah, sometimes they push children born in January or something like that in the year before, and that doesn't always work out well.
Yes, that's right. Every year in school, you have competition between the older ones and the younger ones. The older ones beat the younger ones.
But
Not always, but
you keep on doing the same experiments and coming up with the same solution.
Yes.
Things.
So, some of the problem there, I think, is that newspapers, let us say, somebody publishes a paper, the newspaper science, if they report it, and at least they do report these things sometimes, somebody reads it, their science journalist reads it, and they don't realise that this is not, unless the paper's been very careful telling them, they don't realise this is new work on something, but it's new work on something that's been known for 40 years.
Yeah.
And so they then write their article as if this is a brand new discovery.
Yes.
Even if it's referenced within the study itself, saying
Unless they
this
look,
has been done before.
yeah, unless
we're
they look
just
very, very
expanding.
carefully.
But
and,
if you read scientific articles, you often get like a reference page, like 3 pages of all their articles. So I think a journalist who's under pressure will do article, will do introduction, conclusion, quickly look at the figures in between, and that's it.
That's a very wise way of putting it. Yes, absolutely. Yes.
I mean,
What's so important about it being in them saying that's a new scientific study? I never thought that would make it much better.
I think
Well, the journalists think it makes it much better.
one of the big questions, if you're a journalist on a major newspaper or something like that, or a corresponding thing in radio or television, one of the things your editor-in-chief will ask you when you come in with a story is, why should we run that today?
And that's the answer is, and if he can say it's new work,
Yeah.
that's something that makes a big difference to his chances of getting it published. Remember, he may only get 1 in 3 of the things he puts in published.
Mm.
And he depends for his salary on getting things published. So he's going to put new often.
Mm.
Does the same go for publishing papers in
It's
the
the same
scientific
thing about
field?
publishing papers, that's right.
Oh yeah, if you publish in a
Yeah.
currently hot or fashionable
Journal.
field, then a lot of people will notice because it's currently hot and fashionable. It's not so bad in maths. You can publish. I think mathematicians are less bothered by this kind of thing.
Says a
In fact, mostly what mathematicians like to do is find a nice little corner of the subject that not too many other people are working in, and then sort of potter away at that.
And inhabit it.
That's right. But if somebody proves something new and important and a new technique comes along, then anyone who's in the surrounding area will go off and learn that.
Yeah.
But it's not as competitive in the way that physics, for example, is. I
Or
mean,
biology.
in physics, if you publish your paper on something 2 days after somebody else has published something similar, then they get the credit and you've got nothing.
I'm just letting you know, in 5 minutes I'm going to set you free.
Okay? Kick us out. Right. There's a classic case. There was a mathematical paper which was published by, it's an 8-author paper. But if you look into the history of the thing, it was actually 4 separate papers, all submitted to the same journal, all doing the same thing, but in 4 different ways.
Mm.
And this wasn't a complete surprise because that journal had previously published a new mathematical paper about knots with a thing called the Jones polynomial. And there's a New Zealand mathematician called Vaughan Jones who spotted something everyone had missed for about 50 years, which was a really clever way of distinguishing different knots by doing a mathematical calculation. But if you're in that area and you look at the Jones polynomial paper, you start thinking, you know, I can play a similar trick but in a more general way. And 4 different
groups have done it.
Yeah, so there were 2 groups of 2. No, 3 groups of 2. Anyway, it was 8 people. It was a group of 3. There were groups of 2 and 1 person.
The editor brought them all
They all
together.
submitted it to that journal because that was the natural place. The editor looked at this and said, "Why don't you guys just write a joint paper on this? You've all got bits and pieces of this puzzle. You've all got the same invariant, but you're proving it works in 4 different ways, which are very interestingly related to each other. Go away, put your heads together, and write it." And they did.
What a nice idea.
They did.
Yes.
Yeah. And I don't think that would have happened if you get your 2 teams trying to find the Higgs boson and say, "Why don't you join forces and publish a joint paper?" They'd probably say, "Well, there'd be 700 authors if we did."
Is that because mathematicians don't need very expensive bits of equipment? A piece of paper and a pencil will get you a long way in maths.
Yeah.
It won't.
Although these days you probably need a computer anyway.
But you know, I mean,
a computer's not expensive equipment anymore. No, you know, a really
Depends
fancy computer's
what computer you
a
want.
few £1,000s. Mathematicians can do most things on thousands of pounds, whereas in many sciences you need millions or tens of millions.
Well, I was just thinking when I did my sperm competition experiments in the 70s, the people who wanted to disprove me got together for the same kind of reason. And it turned out that none of their experiments worked, actually, and they couldn't get the thing published. But they must have spent, I should think, £100,000 each on rabbits and so on. And I'd spent that over the previous 5 years, taking sperms out of rabbits, putting them into other rabbits and so on. And I was very interested to hear you say that the 8 of them got together, because there were 8 of them who attempted different tricks, including putting unselected sperms into fallopian tubes, which didn't prove anything one way or another.
Right.
But they'd done really rather odd things. But the 8 of them couldn't get together.
Right.
To do that. It's an interesting thought.
Yeah. I'm sure that in mathematics, the money side of things, the prestige
less
side
important.
of things is different and is less important.
Yeah, as the lady said, yes.
As exactly
Not
as
the
was
prestige,
said.
but the,
No.
it's
The money,
it,
yeah.
you know,
Yeah.
you can.
There are a few exceptions where, for one reason or another, most mathematicians will actually go around the world and they'll visit a department to give a talk, and they'll say, okay, I'll tell you what I'm working on at the moment, and I've got this far and now I'm stuck. Does anybody have any ideas? And a physicist or a biologist would almost certainly try to keep secret what they're working on, because they're worried that somebody else will pick up from where they left off, polish it off, and then take credit for the whole thing. And we just